Okay, so this is a demonstration on how to solder a voltage divider to the project board. As you can see, I have my project board all set up here, my parts, pair of diagonal cutters just for trimming it up. I have my Arduino here just to show you how it goes in, my soldering iron, and got one of these tip clean pads. This one's a little dirty, but should do just fine. Alright, so while my soldering iron heats up, I'll just start by laying my pieces out in the configurations they're going to go. I have two resistors here. They might differ from the exact values that we're going to be using, but in this case, since we have a 100K ohm resistor and a 47K ohm resistor, we just want to make sure that when we get everything set up, it's in the right configuration. I have two lengths of wire here. You know what? I think I'm going to get a third length of wire here, just so that we can be absolutely sure that every part's okay. So we've got three lengths of wire. This can be any old wire. I just have these leads. So first things first, we want to lay it out on the board. And these resistors are through-hole resistors. So I can just take my project board and thread it through any old place. We want to make sure that we don't use up too much space. These resistors really only require 2 holes difference between them. So leaving a little space just right there on the edge. Oh, and it would be good to have a pair of pliers on hand too, because it's kind of hard to manipulate wire. So just so you can see what I'm doing here, I'm pulling these through. Alright, that's the first resistor in place. We're going to pretend that's the 4.7K ohm resistor. So this will be our ground connection right there. That's why I left a hole there, just so that I can solder my lead to that. And I'm going to leave a space between them, and then I'm going to add my 100K ohm resistor, just like so, if it'll cooperate. Okay, that looks good. Now for the Zener diode. This can go in right in tandem with the 4.7K ohm resistor. I'm going to leave a little space just for visibility. I want to make sure that I don't eat up too much space here. So the stripe on the diode, your diode may look a little different, but the stripe on the diode indicates the direction of the diode, and all diodes have a direction. So current wants to flow this way. But in our case, we're going to actually put it in reverse, because the special thing about a Zener diode is it allows current to flow the other way under certain conditions, namely when the voltage goes above 5 volts. So it'll give us a bypass, sort of like a check valve. It'll only open up when it's needed. Otherwise, everything goes through our 4.7K ohm resistor. So this is going to be a little bit thicker, a little bit more difficult to pull through. Just pulling it through the project board. Bam. And bam. Alright. So now we've got our guys sitting on the board roughly where they're going to live. So for the ground connection, I'm just going to color code that with this blue wire, and I'm going to put that right in there. These will probably have to be shifted around as I make them more secure connections. This is going to be our hot wire right in there, and this is going to be our signal wire right in there. So if you'll notice, the signal wire is between the two resistors and just before ground. So that's what that's going to do is it's going to measure the voltage at this point just before it reaches ground. So that'll be the voltage drop across our 4.7 ohm resistor. Just going to tighten everything up here. Alright, we just put them in for final visualization. I'm going to take these out now. My soldering iron should be warmed up. I've got my solder here. Just going to unspool a little bit of that. Try and find the end. There we go. Okay. So I've got some solder. And I'm going to flip the board over since everything's pretty securely in there. And right now I'm just going to make sure that the leads are in order. So everybody in the middle here is going to get connected, and these two guys go to ground. So we've got hot, all these guys in the middle. That's the, let's make sure that's the stripe end of the zener, and the leads coming out of both the resistors pointed toward each other. So put that together. That's 3 guys right there. First things first, we want to make sure that these guys get nice and twisted. So I'll pull that guy over there, pull that guy over there, and just sort of give them a nice loose braid. Pull that down, pull that over. And I'll use my pliers here to give them a nice twist, nice crimp. Make sure they're real nicely put in there, but we don't want to obstruct the pads. Maybe I should have soldered it to the pads first. Yeah, that would have been a good idea. So I'm going to actually undo that. Sorry about that. This is good practice. Let's just start, before we make any connections, before we go crazy, let's just start by securing everything to the board. That should have been my first step. So I'm going to bend these leads out of the way. We'll need them later, but for now I just want to make sure that there's solder on the board and that nobody's going to be shifting around when we work it. So we'll take the solder here, check my tip. Yep, we're hot. Okay, so right now I'm just going to put some solder on the tip of my soldering iron. This is lead-free solder, so it kind of stinks, according to everybody. But that's what we have to work with. In industry, we want to make sure everything's lead-free, in case any kids decide to eat the circuit. Alright, so I've also got a fan going that pull some fumes out. So I just hold it to the board here, making contact with the pad, with the soldering iron, heating up the pad, and solder will flow right there and go in there. So that was beautiful. Now for the next one, there's little bits of metal around the inside of these, so they heat up pretty quick. You can get some solder on the iron that will flow onto the piece, making more contact, but you really want to make sure you touch the tip of the solder to the pad, because we want it to flow with the flux core right inside. So that's 3 down. Let's do these 2 up here. Looks like it's good. The next one, this is the Zener diode here. I'm just going to touch it to the top a little bit, get some on there, kind of come in from underneath. Nope. That's not the greatest connection right there. It kind of balled up on the surface, which indicates a cold joint. Maybe I can get it to flow if I just coax it a little. Yeah, see, the problem with the lead-free solder is you often get this pasty behavior, which sometimes can be annoying. Alright, so now for the last one here, all the way in there. You'll forgive me if I block the light. It's a little hard to keep a close eye on it. I'll try to get the best lighting I can. Come on, stay put. Gently, gently. Alright, that went in perfect. Excellent. So now, we've got everybody soldered. Board's still warm, everybody's in place. So now I can start to tell these guys to twist over. Let's just bring our you know what I'm going to do? I'm going to do something a little tricky here. This is a advanced technique. Not really. I just like to do this because it gives me good contact. Pull that guy in first. Since he's the widest, he's going to be harder to interface with. Get these guys twisted up good around him. Really, we're just trying to make a big blob connection here, so it doesn't really matter as long as everybody is on the same junction. Now I'm going to shove my other guy through from underneath. So that gives us a good idea of where everybody's going to go. I've got my other alligator clip here from my 3-arm, my third hand, that is. Let's see if I can't position them so that everything stays in place. So where was that? Let's just forgive me here. Up. Yeah. That's okay. He's a little above the board, but he'll stay put. Ideally, you want him to look like that. I'm doing this kind of quickly, so I left a little gap there. I wish I had seen that before I started. Anyway, I want to make sure that that's not there. Shouldn't cause an issue, since everybody's pretty well spaced. Alright. So now that I'm going to hold this, get this guy, telling him to stay put. Gently move it around and connect. Alright, so I've got the lead. Probably can't see it. He's just poking through. And I'm just going to twist this guy around like that. I'm going to trim all this up later. This is just a quick and dirty job. Maybe you'll be able to fine-tune the technique, but it really doesn't matter a whole lot because all these guys in the middle here, they're all coming together. It's all one big blob. This was the blue point on the diagram that I sent. So I'm going to get a little solder on there and really just glob it on there. Bloop. Bloop. Boom. So now we have a big ball of solder there, and we want to trim off some of this excess stuff. That looks good. Just make sure our guy here is connected. Yeah, he's firmly in there. So everybody's in there. Everybody's connected right there in the middle. Now we want to do our hot lead. This will be, I guess I'll use this, it won't really matter. Just a length of wire. You want to strip the tips if you have hookup wire, so you'll have to have a wire stripper as well. I have one of those around here somewhere. I'm just using this for convenience purposes. Alright, so I'm just going to give him a little quick twist around. Something to hold on to. Take this guy, he'll hold him in place. And you will hold that in place. Okay. So now I've got the input hot wire in place. I'm just going to do the same thing. Glop some solder right in there. It's nice with these setups, you don't have to be too precise. We're not soldering onto a breadboard or anything, so you can really be pretty liberal with it. Okay. Trim here. Sorry for blocking the light. Don't want to do that. I don't like that. I don't like that at all. Well, that's a fail. I broke off my wire. Yeah. Easy peasy. Heat it up. Let's just do this. That's what a third arm is for. You hold on to him. Just to heat you up. Wiggle, wiggle, wiggle. And out she goes. No good. Let's try that again, shall we? Oh, looks like I put some solder in one of those holes. Now if anything goes wrong like this, it's good we address it now. Fortunately we have a spare length of wire here. That's ruined. And we can start over just about here. And I'll just bend this guy over. You won't mind. Let's get the pliers. Yep, just big old bend right over. Just get them close. Solder will do the rest. As long as they're touching, things should be okay. So they're sort of touching. I'll take my third hand here, make sure it's nice and stable on the side we want it. Let's flip this around. Hold on. Hold on to you. Alright. So, round two. Melted on, melt. Plenty of solder. Boom. Alright. Looks ugly, but it'll do the job. Give it a little tug test. Alright. Seems secure. Still secure. Now for the ground connection. Let's give these guys a little twist. Oh, wait, you know, I can take advantage of the space I left myself. Put this guy right about. Let's keep everybody in nice straight lines. All right, so I'm gonna put him right in there. Looks good. Make sure everything's in place. Get it rigged up with my third hand here, and we should be ready to go. Let's give these guys a little twist. Get them in place, nice and happy. He comes around. He can come around. Like that. Alright, everybody's secure. Add a layer of security. I'm just going to bend that guy down. Bam. Boom. Bada bing, bada boom. Alright. Oop. Oh, don't slip out. Can be very finicky. So, third hand to the rescue. Let's get this guy nice and clipped up so he stays in place. Position here so you can see. And I'm just going to do the same thing we've been doing. Take this big ball of wire, cover it in plenty of solder. Solder just flows right in because we have plenty of contact. Don't need to worry about where it goes, as long as it goes everywhere. Alright, that's disgusting. Alright, that's still hot. And we can trim up the excess. Take him off. There he is. There's our 3 points of contact on a voltage divider circuit. This last little bit of cosmetic surgery here. Take our dikes and boom. Nobody's going anywhere. And again, that's not a disaster, but you like to have everything flush to the board, so just leave 2 spaces between each resistor and you should have enough space. And there's that mistake I made. I had to sit this guy out 1 more space. You know, I'd like to have everything snug, but as I said, I was kind of in a rush here, so this should do it. And then you've got one of these bad boys, handy dandy Dremel tool. You could even cut this guy right out of there, and then you'd have a tighter package because we don't really need all this board, and we want to save it because we can make more projects with it. And there you have it. There's your voltage divider circuit on a project board, quick and dirty. I hope that helped. Okay, one more thing I forgot to mention, since I had the Arduino here, I completely forgot about it, was where everybody goes. So this was our ground lead, this was our hot lead, and I mentioned this was our signal lead. And this lead going into the 100 k ohm resistor, this will lead to the Murphy switch. So that will go from 0 to 12 volts. This is the signal lead at the center of our voltage divider circuit. This will go into the analog 0 pin of the Arduino, or the Arduino shield, but they'll be pretty much in the same point. And this guy will go to any old ground point. Ground should be ground no matter where you are. Ground is ground. Ground is 0 volts. So you could shove it into the ground of the Arduino, but I don't recommend it. I recommend going with the ground on battery if you can reach, or the ground on the power strip board. Either one should work. Ground should be ground, but we don't want to take any chances. So rather than referencing the board, which could have some variance, probably not, we just want to be safe. This guy can go straight to the ground on the battery. And everything should be good. That's the gist of it. Obviously you don't need all this wire. You can trim it up and fine-tune the design as you like it. Really all that matters is that everybody is in this orientation. Alright.